The recording has started. Everybody knows they're being recorded, and I'll get started as well. So thank you everybody for joining. This is the revival of the data and AI architecture group. Um, just starting right now. This is the debut session of our 2023 season. The group hasn't had sessions for a couple of years, but we're really excited to get it up and going again. And you might see Luan on and off as well. I think he might be a core organizer soon. I think he's going to get an upgrade as well. So please, if you can, help us spread the word, reshare, let people know about the group. We're close to, actually, we're already surpassed 800 members. I think we can get easily to 1,000 if we just get the word of mouth out. There's a really good lineup actually for the rest of the year already posted. We got things coming in with some SQL Server architecture stuff. We got a quantum computing primer from a colleague of mine, a friend of mine that's actually works for the U.S. government's National Supercomputing Application Lab in Illinois. We got sessions coming for Fabric as well. We got sessions coming for Power BI modeling. So there's a lot of stuff here. I think there's something for almost everybody. So without further ado, I want to introduce Luan. Luan is a colleague and fellow Microsoft Data Platform MVP. This guy is a massive guru in everything related to data engineering, big data. He was talking about Databricks even before Databricks was cool. So, I'm really excited about this session for today. And without further ado, I am going to mute everybody, mute myself, and I'll leave it all to Luan.
Yeah, sure. Thanks for the words. Yes, yeah, I began the Databricks journeys back in 2014. I think that was the very first time that I saw on Azure. Yeah, funny story that I'm going to leave for the second part of the session. But let me share my screen, and then you guys let me know if this pops up.
Yeah, we can see it.
Okay. So yeah, let me just, if you guys could make this interactive, I would be super happy with that. So maybe you can just put your, show of hands just for me to have an idea about your background, your knowledge. So this way you can fit the content in a way that it could be better fitable for you. So just quick show of hands for those that knows Databricks. Okay, so okay, I have like a couple of people that knows. Okay, nice. And I'm gonna assume that at least majority of them doesn't know about it, right? So that's why I'm gonna give like a brief intro about the Databricks architecture. Don't feel afraid about this image here because we're gonna dissect each one of these segments shortly, right? But what I want to, I'd like to kick off this by saying that when Databricks was first released, basically they started this company accelerating Spark. So the creators of Apache Spark, there's like several creators, but the main three creators, they created the company Databricks to, I mean, in the end of the day, to make it simpler for companies to adopt Apache Spark. Because in the time Apache Spark was, pretty much the new kid in the block in 2014 because the RAN money just decreased, and then was much easier to add processing engines that would leverage the memory RAM to process data. So that's how initially Apache Spark was born and raised, thinking that as a main conception to process data in memory. And then they released Databricks, which would be like this nice environment where we can easily run Spark jobs. So when that thing started, they were pretty much focused in making like giving a good experience for developers and data engineers or people that would like to use Spark in a easy way. They started that journey on Amazon AWS, and in 2014, they kind of opened up this possibility on Microsoft Azure. And in 2021, if I'm not mistaken, they just opened up this on GCP. So now we can, I mean, first off, you can start by saying that if you're using Databricks, no matter which cloud provider, I mean, the main cloud providers you're running into, you're going to be able to run this, right? So having said that, if you deal with Databricks in a correct way, then you could easily lift and shift code between the cloud providers because you're going to still be encapsulated on the Databricks ecosystem, right? But then we have to think a little bit about the evolution of the Databricks. So Databricks was the very first one to become what we usually say in the data analytics world, data platform architecture. And the data platform architecture basically brings the best of breed of each one parts of a data pipelining process. So since the ingestion, the processing, the storage, and the delivery of the data, right? So when we think a little bit about how we build data analytics, we think about these, I would say, these pieces or these layers where you have the ingestion layer, you have the processing layer, the storage layer, and the serving layer. And these are pretty useful because basically it allows you to separate the use of each one of the technologies and the parts that you're gonna move. Um, so it's not that old that Databricks entitled themselves as a data platform because it uses the concept of data lake house. But before I move with the presentation, can you give me another quick show of hands for those that doesn't know about data lake house, which is not a problem whatsoever. So I'm more than happy to explain. Okay, 2, 3. Okay. Okay, so I mean, in a nutshell, data lakehouse allows us to use the best of a data warehousing with the best of the data lake in a combination in a file format, right? So the best of the data warehouse is basically allows you to run a pristine data with ACID capabilities inside of a system. The data lake allows you to have like a cheap storage, and then allows you to either store structured, unstructured, and semi-structured data. But then we had a big issue regarding doing analytics on top of data lake because we could, ended up having like misled information or issues while reading and writing because we didn't have any ACID capabilities built in. Right, so data lake house borns from the concept that it utilizes the data lake engine and then sits on top of this, adding an ACID capability and other goodies that I'm going to talk briefly here. Right, so just looking at the diagram, let's start from the left. Right, so let's say that you have a challenge that you have like different data sources that you need to put into the Databricks platform, and then we have two lanes where we delegate that data ingestion. Either we choose the batch or we use the stream. When we see this architecture, you can certainly say that this is a Lambda architecture because it uses a cold lane and a hot lane, right? There's another way here that could use the Kappa architecture, would be only getting data for a streaming system, right? And then you can decide whether or not you're going to process right now, in few moments, in few minutes, or later. So it's just totally up to you. And how Databricks brings this capability for us to use the data platform, how easy it is to ingest data from data sources into Databricks, right? So as I said, Databricks began with this mental set saying that they would be the best Spark experience ever for developers and people that uses Spark. But eventually they turn into a complete data platform engine that now offers a set of new capabilities built in within the platform. So for example, if you would like to ingest data even from batch or streaming, you can use the computation of Spark, right? So that's going to be your vanilla Spark with the capabilities of reading from JSON, reading from CSV, reading from Avro, reading for Parquet. And also you can use the structured streaming capability that allows you to connect into a streaming source, meaning that now we have the possibility to do either batch and streaming in Spark. And that's vanilla Spark. You can opt for that, right? So you can just use the ingestion of the vanilla Spark. meaning that if you swing by between cloud providers or any any processing mechanism that uses a Spark underneath the hood, your code doesn't need to change because you're using vanilla Spark, right? So the second option here is use the autoloader. And that's pretty interesting one. So the autoloader is enhancement of the structured streaming capability. So that's baked into the Databricks. So that's only available in the Databricks lane. So basically allows you to intelligently read files from the batch location or for streaming location, right? So it makes easier for people to consume that data, and this is a proprietary feature from Databricks. We have the copy into, which is a kind of brand new capability that pretty much goes to compete against the Snowflake capability to fast move data using the staging area and moving that into the data into the data storage layer. So the copy into is pretty simple. It's a SQL statement where it can issue from the batch and now from streaming as well. You can say, hey, create a table for me, or just load the data from that location to that location here, and then we store data securely within the Databricks platform. And we have the third-party applications. There's like gazillions of other applications that allows us to connect, to really easy tap into the Databricks ecosystem and bring this data into the system. But now an interesting point here is if you look at the computation part, you have Spark, and also we have another one called Photon. So the copying to for example, uses the Photon engine to ingest data into the Delta Lake storage. And this is really cool. So when you think a little bit about, the data analytics of the systems nowadays, we see that there's a bunch of nice and well-established technologies. But one of the things that Databricks stands out is because of everything within the platform is pretty much made and baked in an open source manner, right? So when we store the data, we store the data in the lakehouse, meaning that it uses the Delta Lake format. In Delta Lake format, it's completely open source right now, which means that you can use for any other engine that connects or have the capability to connect. So if we just head over to delta.io and we go to integrations, you're gonna see that there's like several integrations that you can use in order to leverage the Delta, meaning that you can process, you can ingest, you can do whatever you want on the Databricks, and you can just put that data into the Delta Lake. And then you can use any other tooling to connect to this data and just use in the way in shape or format that you want to. So that's a pretty nice thing to have because it allows you to have this freedom of choice between the systems. And in the end of this presentation, I'm going to explain a little bit about the Delta Uniform, which is a groundbreaking solution that basically understands all the lakehouse formats, and it's open source, of course. So the Databricks platform brings a whole set of new features as well. So proprietary features that makes even easier for people that utilizes Spark to utilize the platform. So we have Delta Live tables, which we're going to discuss in a bit. We have the autoloader, which I explained it here. We have the Unity catalog. So that feature is just for the people that seeks the data governance style. So with the Unity catalog, you can connect with the multiple assets within the company and then can start to bring the governance inside of the Databricks. And you have the jobs and workflows. So they released something really nice called the Delta Live Tables, DLT, which is kind of booming off right now. Everybody that basically uses Databricks building new projects, they are always dipping their toes in the Delta Live Tables. It's it's a it's a UI intuitive way in how you're going to process your data. So basically, you create your process logic, and then you decorate that logic with a function, and then he finds out how to get put in a nice graph. I'm going to show you in a bit. And also we have the developer experience and the data visualization. you are able to connect using Power BI, Tableau, Locker, ClickView, and other engines into the Databricks or into the Spark engine and then access the Delta Lake. So the recommendation would be to use the Photon engine, which is an engine that works faster than the Spark per se. So this is an engine that was, handmade and cooked inside of Databricks. Is a completely new way in how they access the storage layer, which is pretty interesting. If we have time, we're going to dive a little bit about how the default engine works. And we have the developer experience, which allows you to either connect through the Spark or Delta. And now you have the DB libraries, which is the Databricks SQL. That's the DB SQL or the Photon engine pretty much encompass the idea of the data warehousing. So now we have the data streaming, bringing data in near real time or real time into the cluster, into the Delta Lake. We have the data engineering that we can use any programming language that is just signed with Apache Spark to code, or the Photon engine to write SQL. And then we have the data warehousing, which is the Databricks SQL. So that's why now they entitle themselves as a data platform, because now you can have everything in one single place. And then it just becomes your one-stop shop solution for process data, just ingest, process, and serve data in one single location. Okay. Right. Yeah. Let's park the questions for later, right? So as I said, just looking here, maybe in the middle. So we're gonna see that we're available in GCP, Azure, in AWS. But also it's worth to mention that it's available on Alibaba as well. So you have the capability to use Databricks in these main cloud providers. And also it's really important for us to know that all of the features, pretty much all the features that Databricks offers, it's based on open source products. So Spark allows you to write any code anywhere. Delta is a storage engine that allows you to use the data lake house concept and gives you a lot of features because of that. Asset capability, schema on write. It allows you to get back in time. You have the time travel capability. You have change data feed. You can just incrementally see the changes that happened from the last time that you queried the table. That's fantastic. You can you store the metadata and data in different ways. You can read, you can write two batches or a streaming and batching the same table at the same time. You can version, it automatically versions the table for you, and everything's open source, as I said. Delta sharing is a protocol that allows the sharing between Delta, not between Delta, but not between Databricks, but Delta per se. So you can basically share Delta live table. You can share Delta tables between different organizations and people and customers. And this is open source as well. And Redash, for those that doesn't know what Redash used to be a pretty famous, it is still famous visualization engine open source. And then Databricks actually just partnered up with Redash and just builds this capability inside of the platform, right? So that fills up pretty much all the main personas where we have inside of the data analytics spectrum nowadays. So for data engineers, you can just run your code. You can simply program and just write your Spark program. As a software engineer, you can still write code that glues all the pieces together. You can add tasks, you can add CI/CD, and you can do pretty much the Git flow architecture. As a data scientist, I'm just, this presentation is going to be solely focused on the data engineering, and you're not going to be able to pass even, 10% of it. But for the data scientists, they have another area exclusively made for them. So MLflow, which is another open source product, it's baked into the Databricks platform, which is pretty good because you can just do amazing things on the data science spectrum. And you have the analytics engineer, the possibility to write SQL, read SQL, and just query data, even in a federated way. So the Databricks SQL allows you to federate queries. So you can query, for example, data that sits into S3. You can query data for example, that sits on BigQuery, for example. So it uses the JDBC connector behind the scenes to connect to that. So then you can just, have this federated location where you have all your data into a place. And what about the proprietary features that the Databricks brings today into the table, right? So let's just have a closer look here. Okay, so autoloader, which is incrementally process new data files as they arrive in cloud storage systems. So basically, it fast recognizes that a new file has arrived and then automatically sends that information to the autoloader, so autoloader can better query the file and load into the data frame, which is inside of the Spark structure. Delta Life Tables is a framework where you can either use SQL or Python, and then it's going to create a beautiful, nice interface for you where you can see your data flowing through, in it to end. We have the Unity catalog, which is the unified governance with data analytics and AI. We have the jobs and workflows, so now we can schedule complex logics between how many jobs and the sequence between these jobs, and also increment them using the workflows. Which is pretty much the Delta Life tables. And we have the latest release of Databricks in Azure specifically is the Databricks SQL serverless. And that's a pretty cool stuff. So now you don't have to provision, you don't have to be concerned about, choosing which, in how if you're going to pause or resume your cluster. Basically it understands this automatically. So whenever you run the query, the cluster is already warmed up. So it's really fast to query the data and then pauses, and you don't pay for that. You just pay for the execution. Pretty much the same concept of the other data housing engines as well. Now, I would like to briefly talk a little bit about the data lakehouse concept again, just to make sure that everybody understands this, and then we can just move to the following ones. Well, as I said, the data lake doesn't offer asset capabilities, neither like a mechanism that guarantees that that transaction it's correct or not. So this is one of the main issues when you're trying to apply data analytics at scale, because you may stumble across an issue of you need to guarantee that's a credit card transaction has performed, or you have to guarantee, for example, that certain specific invoice was made correctly, or you need to guarantee that that specific transaction is atomic. It's either true or false. So that's how we ended up by moving and just building this new concept of data lakehouse. Now, important thing is who brought this up, right? Who was the one that coined it, the concept of data lakehouse? Again, Databricks. Databricks was the very first company that builds the concept of data lakehouse and actually explains a little bit about this and it started with this in the internet. I had the pleasure to be in a conference where the Engenharia, which is one of the co-creators of Apache Spark, they released this open source, completely open source. It was on Amsterdam in 2021 or 2020. Yeah, 2020, time flies. So it was magical. And now since then, we've seen like huge adoption of customers using that. To be quite honest with you, we don't see Spark environments without Delta anymore. If you're starting a new project, you have to strongly consider using Delta Lake as your lake storage, because that's going to allow you and brings a lot of new capabilities off the shelf for you. And yeah, so Delta Life Tables it's something really nice that I would like to show you now. Which is basically, as I said, you just write your Spark or SQL code, and then it transforms this in a nice UI where you can see all the flow flowing through. This is really cool because it gives you, again, the ability, the same for people that knows a little bit about Airflow or whatever. You just write a code and then creates a DAG for you. And that gives you a really nice idea in how you utilize this, right? And also allows data engineers and other people to even, tap into this pretty easily, which is another big thing. Yes, it's perfect. Let me just show something interesting here. Okay. So the last thing before I just go into the Databricks environment and show a little bit about how does it work. It actually changed quite recently, which is nice. It's about the Databricks SQL, right? So Databricks SQL is the newest, I would say, feature on the into the Databricks platform by itself, which actually brings a whole new level of performance, which they call the Photon engine. So the Photon engine is a next generation vectorized query engine that was written in C++. So then it's not Java anymore. So they are actually going even further in how to control the data and vectorize the data in memory. So they just built this from the C++ from the ground up. And if you, for example, comparing, it's not apples to apples, but if you're comparing Spark against Databricks SQL, basically you can get 2 to 3 times more performance just by switching between the engines. And reason of this is it uses, of course, all the lakehouse, all the Delta Lake capabilities to create a really nice execution plan, but also because of this Photon engine, it's pretty much optimized. It allows you to get even more performance on top of the Databricks platform, right? So as I said, if you would like to ingest the data using the Photon engine, so I'm going to show you how we're going to provision this and how we do this on the Databricks portal. You can either choose the copy into autoloader or 5 so that's going to allow you to do this. Right. A little bit more about the Photon, because I think it's going to be important for people that are here to understand a little bit about how that piece works real quick, like 5 minutes. And then you're going to be able to better understand why that engine supersedes the Spark execution, which is, really fantastic. So as I said, the Photon engine, it's something that was created and baked inside of the Databricks. It's totally compatible with the Apache Spark API. It's completely native and transparent and seamless in how they interact with that. And basically, that C++ was made and crafted thinking about how modern hardware today operates. So in the way that we query, in the way that we access CPU memory storage is a little bit different from, 20, 13, 14 years ago. So they actually just built something that really understands these new marketing trends and how they're going to query data pretty fast. And if you look a little bit about the bottlenecks that we face nowadays is, if you look a little bit about performance, in overall, we have storage, network, and CPU, right? So that was pretty much put in mind in terms of how the C++, how this engine would be built and crafted in such a way that could reduce the bottlenecks when we're either using storage, network, and CPUs. So we had a huge evolution in network. We had an amazing evolution in storage as well, but we don't see too much anymore evolutions on the CPU. Yeah, we have the quantum computing. It's just knocking on the door right now. That's going to be a huge leap for us as human beings. But so far, if you look for these 3 verticals, we see that CPU is one of the hasn't been evolved drastically over the last 5 years, right? So the engine is pretty much focusing how in how you move data and how you store data efficiently inside of the system, so you can query data even faster. Um, and that was just pretty much that benchmarking stuff, which to be honest, I don't agree too much, because benchmarking, whenever the player that's doing benchmarking is winning the case. But anyways, it just kind of demonstrates a little bit about the performance and how that behaves in the overall TP CDS. So they pretty much ran a comparison between Snowflake and Databricks SQL, and they get, like, with Databricks SQL spot instance, the query, which was spread and split in 4 phases, which is loading data set, processing sequence of queries, processing several concurrent query streams, and running data maintenance functions for insert and delete. So the SQL is just a comparison of $146 for the query, which is 100 terabytes if I'm not mistaken. And then on Snowflake, the equivalent was 70,091. And yeah, just going a little bit deeper in terms of how the thing works. So they have this concept called a Delta engine. So let's imagine that you have any process engine that I showed you in the site like a couple of minutes ago. You have this integration. So let's imagine that you have pandas, or you have Spark per se, or you have any SQL statement coming into the Delta. So inside of the Delta engine, you have this Photon execution engine. And that Photon execution engine is basically is an array of one dimension in memory. So it stores the data in memory and does a bunch of analysis and transformations on the fly. And that's pretty nice. So if you see here, they have something called inside of the Photon engine called adaptive batch level. So basically, that adaptive batch level leverages the capability to, in execution runtime, it changes the execution plan, and it changes how they store the data into the memory to make it even faster to access. So as I said, compared like the vanilla Delta engine without Photon and Delta engine with Photon, you may realize that you have around 3.3 or 3 times faster, meaning that if you pick the Spark cluster and you provision equivalent Databricks SQL and you run these two processing engines and you do a test of running a SQL here, a statement here, and you run another statement on the Databricks SQL, that SQL could be 3 times faster only by hopping between these two. And yeah, that's what I have. So let me just bring the Databricks panel here. So this is a brand new one, a Databricks panel. We used to have this actually split in different blades. So we used to have the data engineering blade, the data science blade, and the data warehousing blade. But then they just put this in one single location, and they just differentiate about maybe the personas and what you're targeting to do. So here you have like machine learning, which I'm not going to touch in this presentation. The data engineering, we have jobs, data ingestion, and Delta Lake. And SQL, we have all the capabilities for that, right? So the first thing that we start to do is when we build the workspace. So the workspace could be like a series of stuff, but usually that workspace is configured with the repo. So you configure a repo in the GitHub, for example, and then allows you to connect all your scripts, and everything is going to be there. It's going to follow the Git flow, and it's going to simply work end to end. Okay. The first thing, we start with the first things first, right? So the first thing that usually what we do when we are using Databricks is to create a cluster. So you come here to create a compute. And then, yeah, there's like several options here, but what I want to show you is you choose, the level of performance that you'd like to have, you see? And there's like different options. You have Delta Cache Accelerated, which pretty much creates like a warmed up location that sits in between the code zone and the run zone, and allows you to instantaneously query data even faster. So you have like different configurations here, but also you see something called use photon acceleration. So this is really important stuff. So basically, I said earlier in the presentation that Databricks SQL uses the Photon engine. So when they built the Databricks SQL, they built the Photon engine to kind of be the cornerstone of the Databricks SQL. But then they realized that for some operations that runs on Spark, Photon runs much faster, and these transformations and these workspaces that runs even better on Photon, they are pretty much tied into how they are putting things on memory. So whenever you have to do a shuffle oh, whenever you have to do like a comparison in memory between, data frames or whatever, the Photon engine will perform this. It's going to outperform over Spark. It's going to perform way better than this. So you can have the option to leave this enabled, right? But then just bear in mind that you're going to have more DBUs to pay. What is DBUs, Luan? DBU is Databricks units. So that's how we bill, Databricks bill customers. It's based on that. So you're going to pay the price of the machine per se, right? It's like you're going to play the DS4 V2 machine, and you're going to pay between 9 to 27 DBUs because I put it like the mean and max workers. But if I just put this as, 3 workers here, then you're gonna see, again, look at this. Yeah, so then you're gonna have 12 DBUs to pay. Okay, so then I'm just disabling out the scaler. Right, and this is basically the option that offers you to create the Databricks SQL. Sorry, the Spark cluster. Something really important. It's how Databricks encapsulates the jars and all the stuff. For those that know Java a little bit, knows that there's like the jars dependencies. That is a it's a huge hassle for people that uses jars or uses anything related to Java in terms of how we're going to build the jar, how we're going to integrate the jar, the version of jar, so on and so forth. So Databricks built something really nice called a Databricks runtime. So Databricks runtimes is just things that Databricks runtime as a agglomeration of all the jars and everything tested, battle tested, and then they create a version for this. So whenever they comes up with this version, they just release here in the panel. So for example, the version 13, you have like Scala 2.12 and Spark 3.4.1. But also, this runtime is not only about features and integrations between Spark and the jars, but also inside of the Databricks runtimes, they brings a lot of new capabilities and features into the table. So stay tuned for that because that's really nice. You can go to the Databricks runtime version site, and then you're going to see all the capabilities that each one of them offers, and those are really nice actually to know it. So this is how you create a Spark cluster. And yeah, this is one way to do this, or you can either come here and say, hey, SQL editor, SQL warehouses, and then you can create a SQL warehouse. And that's really nice because now serverless SQL warehouse has been enabled for your workspace. So I can come here and create a warehouse and say, hey, just meet up. And then I can choose the cluster size. Could be a really beefy one or like a small one, totally up to you. You can say, hey, auto stops after 10 minutes of activity, scale for 1, whatever. And then you have all these options here, right? Serverless, which is a cost effective. You have the Pro, which basically gives you all the features from the Classic, plus some features regarding performance, because you're going to have a more standard SLA. You're going to have this always up and running, depending on the auto stop that you have, and how you'd like to, if you're using spot instances, which is a really nice strategy if you want to avoid costs, you can just, choose between cost, optimize it, right? And then you create a Databricks SQL engine, which allows you to connect with these other tools instantaneously. Right? So it gives you like the host name and gives you the JDBC connector, so you can just easily, connect with different things that you want here. So open up the SQL editor. That's something really good. It's about how the Databricks SQL integrates with the Hive Met store. That's really nice. So it basically does this automatically for you off the shelf. You don't even need to be concerned about it, right? So it just finds, it doesn't matter if you're using Spark or if you're using Databricks. I mean, just bear in mind that everything is going to be stored into the Delta Lake in a place into the storage. Could be on blob storage, could be on Google Cloud Storage, could be on S3. And then basically the Databricks SQL is going to be able to see because of the metadata. Right? So you can super easily come here, select stars from, then let's just put Yelp. Let me see if I have something on Yelp. Yelp, no data here. Let me see here. I should have data. Yeah, I have here. So this is the users sales. So let me execute that. No. Okay. It's executing. So you can see how easy it is. So it's warming up, right? It's just bringing the cluster up to run. And what is cool about this is it offers you instant access to things that you want to do. That's really nice. My other queries that disappeared here, which is really bad, but I'm gonna leave that running. Oh, it ran. Yeah, you see the data here that ran successfully. You have a really nice UI to debug. That's super cool. Actually tells you pretty much everything about, rows returned, rows written, if you have any rows written, partitions, files read, and stuff like that. So you can even go further and see through a graph view what they did. So they scanned the Hive meta store to see where the data resides. Then they applied some aggregation. Also another aggregation here on top of 1000, and they see how many megs of RAM was assigned to it. And they transformed columnar to row to show that in the limited data. So basically, also something really important here is just it shows you through the different assets here how long it took. So it took like 77% of the time scheduling rather than running, right? Because of the very first execution. So now let's get back here and let's test it out to run this again. Yeah, it was way faster. But then I would like to show something they changed pretty recent that. Okay, now you see, right? The scheduling was 80% of it, whereas the running was 92. But something that I would like to see is they changed that if it's cached. Let me see if it's cached. No. Okay, yeah, nice. Here, bytes read from cache 100%. That's another cool stuff on the Photon engine, which is, you have like for some period of time, your query stays there into the Photon engine. So whenever you just use the same footprint, it actually recognizes that this is in memory or in a warm up zone, and then brings to you without going actually into the correct place. And he knows that through metadata. And that goes entirely from cache. So you're not paying for reads and writes. You're not just spending cluster time on that, which is really cool. And the last thing that I would like to show you is the Delta Life tables. As I said, Delta Life tables is really nice stuff. You guys should be ready to see more and more, I would say, updates around this feature. So basically, you write your Spark code in the way that you used to, but then you decorate your code in such a way that is going to build a DAG for you. So then you're going to be able to see through a graphical design the end-to-end flow of this process. Yeah, so we talk a little bit about the data engineering. We talk a little bit about SQL, how to provision the cluster. And let me just quickly show how we do a federated query, it's a really nice cool stuff, right? So for example, if we would like to query from the Snowflake, we can create a table passing the parameters, and then you can query that one here using the federation. that allows you to actually just access different locations, which is nice as well, which is a really nice feature. Let me see if I have others. For history, last, I did something. I've lost mine, but it's fine. Yeah, let me show the workspace real quick. So here, just showing how would be the experience in a notebook, right? So this is how Databricks gives you the ability to write your code. So you can choose which language you would like to choose, Python, SQL, Scala, or R. And then you can simply write your scripts, right? So if you're just putting like the magic SQL, you're using SQL. If you're putting magic Python, then you're just using Python. And then you can just swing between them and just write your logic here. Before we finish, let me see if I can show you the Delta Life tables. I'm gonna wait a little bit to initialize. It may take like 3 minutes tops. So in the meantime, Warner, if you would like to open up for questions, I'm more than glad to take them.
Yeah, absolutely. I don't think we have questions right now, but if everybody has some questions right now, feel free to type them out. This is a lot to digest, obviously, but I mean, I think everybody here in this call, if you've been keeping up to date on these cloud platform competitors, right? Databricks, Snowflake, Google with BigQuery, obviously Microsoft with Synapse, and then Fabric. They're all, working towards this kind of like super integrated environment, right? So they all are offering data lake with warehousing, with maybe some sort of ETL tool, et cetera, et cetera. Here's a question from John. Says, how does Databricks compare to Informatica? Have you used Informatica before, Luan?
I never. I'm a Nutella one.
Yeah,
I'm just back in the SSIS days, but
yeah, I think, well, Informatica is mostly, well, this is on my experience with Informatica, is that it's a tool itself that you use. Like the only way I've used it in the past is when, let's say, I was doing some warehousing from a particular system to, let's say, Oracle, and then we would use Informatica to do the ETL, right? So this is Databricks, because of its ability to federate connections and all the other stuff that you showed us, like the Delta Life tables, you can use Databricks as your ETL engine, right?
you can.
Yeah.
Yeah. There's a couple of questions. I love this.
Yeah.
Would you use Databricks for transactional versus traditional data warehouse? Nope. Just I think transaction still sits on the transactional layer with data stores. But kind of that's a little bit weird, Warner. I don't know if you know it, but Snowflake is bringing something called a Unistore that allows you
Yeah.
to put transactions, right?
Snowflake is trying to do both. Yeah, Snowflake is trying to do both. It's in preview right now. It's going to have hybrid tables.
Yeah.
I haven't heard anything similar from Databricks yet, trying to do
Yeah.
both. Right now, though, even the Snowflake solution is still just preview. And like you said, most people they'll use transactional, they'll use a PostgreSQL, they'll use a SQL Server, they'll use an Oracle,
Yeah.
and then they would use Databricks only for the analytical workload.
But wouldn't be surprised if the upcoming years they come up with something because Snowflake is
Yeah,
already
there's a
bringing
lot of
this Unistore.
competition.
Yeah,
Yeah.
so there's a lot of competition on this.
All right. Let's see. Shannon has another question here. You want to go for it?
Yeah, would there be any drawback in performance to not using Delta Life tables versus using traditional workflow? That's a really good question, Shannon. No, there is no performance implications around this. The only difference is that, so let me see if I can show you. Actually, I can, of course, I can. So as you see, really nice, right? You just have your streaming tables, and then you're just putting this in the middle and just putting in the gold model. So I'm just basically using a medallion architecture that gets into bronze. It's sanitized a little bit on massage, on silver, and is delivered for the end user on the gold medal. So how did I write that code, right? So if you click here, This is the notebook that is linked up with that graphical UI. And look how this is easy, Warner, to do it. You just have to come here, just build the script and say, hey, create streaming live table. I can put properties on it as well. And then I say, hey, select from cloud files. This cloud files capability is the autoloader that I told you about. And then say, hey, just reads everything that falls into that folder and maps and infers the column for me automatically, please. And then it builds this table. And then the other table is built with the same way. And that's really nice. This is really cool. You can create a streaming live table, and then you're referencing the join between these other two tables. But not only that, you're adding a constraint. You can even add data quality checks on top of this, saying that, hey, there's a constraint on valid user ID that expects user ID to be not null. On the violation, and I have three ways to violate. I can violate by dropping, I can violate by just letting us know, and I can violate by just stopping the pipeline. So just really depending how you would like to interact with the violation. And then you just write your, summarized query on top of the live streaming table. So because you used this hints here, it automatically detected the Delta Live table for you. So it's just really the way that you write the code, which doesn't change too much. In the SQL is just super easy to do. And I can show you how that's done into the PySpark spectrum as well, which is pretty easy. And then you're going to be able to see the whole shebang here.
We got a couple of other questions. You want to do them now, or just...
Yeah, I'm gonna do it. Just let me show you here real quick. So just channel, the only thing that you need to do is that you write your function as you used to do, but then you say, hey, at dlt.table, and you decorate the table, or you decorate the function, sorry, with this, and then automatically understand that this is going to be a DLT table, right? You can have a DLT view, which is a function that does like the enrichment, but doesn't persist the data. And the final result is just sending to a new table in a domain. So they're going to build the pipeline for you. Yeah, I'm just running out of resources, by the way. Next question. Okay, can you tell me about liquid clustering and when it's necessary? Yeah, that's a nice question. So liquid clustering, it's something really brand new on the Databricks spectrum. But basically, if we look the old days and how we optimize the Databricks, we used to do for partitioning, right? So whenever you have like a big table, you used to partition the table to get more performance. Then we moved to the second era, which was, hey, don't do this, use zero ordering. So on the Delta Lake, you can choose how you would like to structurize the files in a way that would be faster to query with this. The liquid clustering does everything for that for us. It optimizes the delta automatically. So this way, whenever you query the data, the liquid clustering is going to be able to understand what's going to be the best way to interact with the delta live table. Sorry, delta table. Should I use constraints in the DLT view? You can, just the same thing. Is there a way to use interactive mode in notebook using delta live table? Is not available in pipelines. Is not available yet. Yeah, it's not available yet. I mean, you can just do this interactively and changing, but then once you link with the delta live table, you can click here, and that's going to point you to the data, to the delta live table that you'd like to use it. But for now, you just don't have the capability to do this interactively. Oh, it's good. We are on time. Lots of questions. Loved it. Yeah, sure.
I think there's only one left.
Is there any other? Have I missed some? No, I don't. Right?
No, we're good.
Okay. Okay, very good.
Cool. Well, we only have 4 more minutes. I don't know if you want to have some parting thoughts.
Yes, when to use DLT
Oh, wait, we
and
got
when
a
not.
couple of people that some parting questions. Maybe I'll just use the rest of the time for the questions.
Yeah. Are there tools that help build this query? Great question, John. So if you're building like these queries and just starting to get acquaintance to and building these queries, what I suggest to you is just head over to the SQL editor, write your queries here, make sure that they're just working, and then you can lift to the Delta Life tables. Or you can do instead of the notebook, if you want to. It's just really depends on how you'd like to feel. You feel better either in a notebook cache or in a SQL editor. So when to use DLT and when not. There's just only one occurrence that I would think, Lucas, that you should not use DLT. And you should not use DLT whenever you don't use Databricks. If you use Databricks, you should use DLT. That's it. That's my recommendation. Yeah, I
Okay.
think we can use this 3 minutes to kind of sum it up a little bit, just in 1 minute, and then I leave two for you. So then you can
Yeah, for
just
sure. Just
finish
go
off.
for it.
Yeah. Yeah. So basically we saw, guys, that the Databricks offers today a huge lakehouse platform, which allows you to ingest, process, store, and serve the data within the platform. So I can tell you that you can build entire pipelines end to end solely using Databricks data platform because I do this for a living, pretty much. So it gives you a whole breadth and set of features that makes it even easier for people that uses Spark or uses SQL, which is more common, to build pipelines. And then you can decide whichever feature you like the most, and then you can use them to build your data pipelines, knowing that since you're storing the data into the Delta Lake, it opens even more freedom because you can choose which other tools you're gonna put into your zoo of analytics. And that's pretty much that.
Okay, well, appreciate it, Luan. Thank you for again. You're the guinea pig. You kicked off the year for the group, and I cannot thank you enough for committing 1 hour of your time to helping everybody. And everybody that joined us today as well. We really appreciate it. You could be doing anything in the world, but you decided to take an hour of your day and come and learn with us. And we really appreciate that. As I said before, I'm going to be creating a YouTube channel for the group, and I'm going to be uploading the recording as well into there. And I'll be posting the link to the YouTube on the meetup description. So we will all have them as we go along. We'll start creating a big archive of all these meetings. But until next time, everybody, thanks for watching. Stay safe. Take
Thanks so
care.
much, guys, for
Bye-bye.
having us. It was a pleasure. Bye bye.